Hello to everybody who's on the webinar. Welcome to the second webinar on livestock modeling. 2 weeks ago, we gave a very general introduction to livestock modeling and crop livestock interactions and farming systems analysis. Today, we will go into some of the more technical details of livestock modeling, and we will take the example of the LivSim model and show you, well, give you a brief introduction to that model, talk a bit about data requirements and model setup. And I'm talking here from Wageningen. I have my colleague Mink Zijlstra next to me. He will also be joining us in Vikvols, so you'll all meet Mink next week. And Ramilan from ICRISAT also contributed to this webinar. So this is just an overview of what we'll be talking about today. So yeah, a bit of the technical background in the first parts of the webinar, and then we'll be ending with a short example. And before that, I'll also show you how the model LivSim fit within the AgMIP Regional Integrated Assessment modeling framework. I would like to keep more general questions on the content to the end of the presentation, but if there are any burning questions for clarification, you can type them in the chat box. And then after each of the sections, I will pause for a little time, and then Shari can share the burning clarification questions, if there are any. And if there are none, then we'll just move on. Note that we will not have time to go into a lot of details in terms of questions, because we have quite a bit of slides and content to cover. So I think we better get started, having said that. So we start with a brief history of the LivSim model, and I also wanted to illustrate the applications so far of the LivSim model. LivSim has been developed by Mariana Rufino. She did her PhD thesis here in Wageningen in our group, and she's really the mother, let's say, of the LivSim model. And so her PhD thesis, in which she describes the model, is freely downloadable from the Wageningen website. And I would encourage people who are intending to use the model to actually do that and pay particular attention to the appendix in the PhD thesis, where a lot of the details of the model are given. I've listed here 3 useful publications in which the LivSim model is applied, and these publications, they come from different countries, different regions in Africa. There's an example from Kenya, an example from Mali, and an example from Zimbabwe. So countries where the AgMIP project is also working. So I think these publications can be very useful for everybody who's interested in livestock modeling. And if you have any problems downloading them, just let me know, and I can send you the PDF of the paper. Good, so let's have a look then at some of the applications of LivSim. So LivSim has been used previously to look at the effects of feed amount and feed quality on body weight. You see an example of such an analysis here. So here, the feed scenarios that are compared are Napier versus Napier plus maize stover. That same scenario plus a certain amount of concentrates, and then optimal feeding. And so with the black dots, you see how body weight is evolving over time.
Katrine, can I interrupt for a second?
Yeah.
This is Alex here. Can you just help me understand, when we deal with a crop model, we're dealing with basically the average over a hectare in terms of the area. Should we be reading this as representing one cow or one livestock unit, or is this a population?
This particular graph is one cow. At the end of the presentation, I'll show you how we can deal with that question within the AgMIP setting, let's say, and I'll show you how you can look at one cow, how you can look at a herd, and how you can look at a population of farms.
Great, thanks.
Yeah. Okay, another application is this one, where we look at different feeding practices on milk yield. So apart from body weight, of course, milk production is an important output of livestock keeping. And here the farmer control, in which cattle are just roaming around, is compared with a scenario in which the cows are fed with supplementary feed to fill the feed gaps, and then a third more optimal scenario in which the cows are kept in a stable and fed a very good diet. And then a third example is from work in Zimbabwe, where here in this case, answering a bit of Alex's question, we're looking at village scale outputs. So here we're looking at the number of cattle and then the herd size for the village expressed in tons of live body weight. And again, we're looking here at different scenarios of weather, average weather, wet years and dry years, and then different management options of the crop residues. So again, here you clearly see the seasonal variation, and you see also a difference between the different feeding scenarios. Okay, so we move on to the second topic of the webinar. So if there's any burning questions, then I can take those now.
Hi, Catherine, I am on the phone because I don't have internet connection.
Hi, Ramilan. Good you're with us.
Yeah, I'm on the phone. Yeah, so unfortunately I couldn't get an internet connection. So.
Okay, but that's great. Great you could join.
Yeah. Yeah.
Okay, so let me dive into a bit of the technical stuff then. So this is a slide on software requirements for running LivSim. So this is basically for people who are actually going to use the model, and it's just good to keep those things in mind, and to make sure that you have an R software on your computer, that you have R Studio on your computer, and maybe if you want to come really prepared, that you also install the ABind library on your within your R environment. And then basically at the workshop we'll provide you with the LivSim package, and then you'll be ready to go. So that will help if you come prepared with those R versions on your computer. I hope that is clear. If so, then I'll tell you a bit more about the LivSim structure and functioning. So there's a couple of things that go into the model. So model input data and parameters. And basically those can be broken up into 3 categories. One is on settings. That is about herd management and things like simulation time. Then we've got input data. That is particularly about the composition of the herd, the initial herd, and input data on feed quantity and quality. And then we have, of course, very importantly, we have breed parameters. Just like you would have crop cultivar parameters, we also need breed characteristics for the breed that is common in the region that you are modeling. So that input data goes into the model, and then for each individual animal in the herd, the potential growth and the potential intake is calculated, and from that the nutritive requirements are derived, and those nutritive requirements they are needed for maintenance, for growth, for walking, for gestation, and for lactation. And comparing the requirements against what is available, what we provide in the input, we calculate the actual growth and the actual intake of feed. And then from that actual intake, the outputs in terms of milk, in terms of calves, and in terms of manure production are calculated. And we have some settings in terms of herd management. So, for example, how often cows will be sold, things on feeding strategies are specified also here. And then for all the cows in the herd, these things are repeated, and like that, we simulate livestock productivity. So these upper components are fed into an Excel input file, and we'll show you some screenshots of that. And there's a macro on that Excel file that then generates CSV files that are read in by the model. Now, the model is basically an R package that consists of several functions, and that R package is built from a source code, and everybody can consult that source code and can actually also modify it. Now, for the AgMIP purposes, and for other projects in the past and other current projects as well, basically you can write your own script around the package to run it. And for the AgMIP purposes, we've developed a script that can be used by the different teams for the regional integrated assessment analyses. And I'll talk a bit more about that later on as well. Some other specifications of the model then, well, we use a monthly time step to simulate livestock productivity. We model individual animals. So for each animal, their age is recorded, their body weight, their feed intake, their production, etc. And the model also contains some stochastic elements, and those are related to mortality, to conception, and to the sex of the calves. Now, those stochastic elements, they can also be removed, so you can also run LivSim in a deterministic mode. And that means that, for example, when we talk about the sex of the calves, that you will have a male and a female, and a male and a female calf, yeah, how do you say that? Alternating between the two sexes. And the advantage of that is that you don't need a lot of runs to average out these stochastic elements. Okay, so any questions so far on LivSim structure and functioning?
Katrine, this is Alex again. I hope I didn't miss this, but could you say a little bit more about, I'm looking for ways that we can either do adaptation or climate comes in. I know most of it is through the feed quality and feed quantity, but could you say something about breed characteristics? What actually is that if we are saying, you know, improved breeds?
Yeah, okay, I'll talk a bit about the breed characteristics in a minute, so maybe it will become a bit clearer.
Sure. I'll wait on that.
Yeah, in terms of improved breed characteristics, one thing you could think of is, for example, mortality rates. So those could, for example, be lower with breeds that are adapted to hot or dry conditions or something like that. Or they could be lower if veterinary services are improved. So that could be one example. And then the other one
is the herd management and the requirements for walking. I could imagine that in a hot and dry environment, walking would have a higher requirement, but I'm guessing that is more of a parameterized rather than climate actually coming in.
Yeah, it is. So the walking requirements, so that is something you can specify in the model, how many kilometers the animals would have to walk every day. So there you can play with. So that it's not a breed-specific parameter, that one.
Interesting, but it'd be interesting to see if maybe we could. I don't know if I'm thinking off the top of my head here, but some kind of a 1 kilometer under good conditions is the same as 1.2 kilometers under hot conditions. I don't know if there's some kind of way we could think about that. I guess that's jumping ahead of ourselves, but that would be interesting. Maybe in the longer run of model development.
Yeah, that we could think along those lines. Yeah, definitely. Any other questions on this one? Okay, if not, then let's move on. Becoming a little bit more practical then about how to run LivSim. So basically, there's two steps that you have to complete, and like this it sounds really simple actually. So first you set up your model, and then secondly you run it. So that's super easy. But setting up your model means that you have to build a package, an R package from the source code. And Mink is writing up some user guidelines for everybody, and those will be ready. They're ready now, actually, but we will share them with everyone at the workshop. So I don't have a detailed slide on that here. And then basically for running it, you have to make sure that the package, that your working directory is the same as the folder where your package sits. And then basically you just run the script, and the model will produce outputs.
Katrin?
So, yeah.
Pakistan has asked, will you provide R script for LivSim?
Yes. Yeah, we will. We will come with the source code, and we will help everybody to build the package from the source code. And then, as I said, we have this customized script that is built for AgMIP purposes. It's the script we used within the clip team in the first phase, and I can imagine that we will have to adjust it slightly for the purposes of the different teams, but we will come with those, and yeah, it will be a good starting point for the other teams as well. Okay. Then a little bit about the input data. So first of all, of course, very important are the breed parameters. The most important ones here are about the potential or the maximum and the minimal weight. Parameters around calving rate, feasible set for reproduction, and weight at birth. And then parameters that tell you more about the milk production, so the lactation length, the daily milk production, and then parameters around milk fat and protein content. This is a screenshot of the Excel input file where all the breed parameters can be specified. And so if we look, for example, here, we see the maximum body weight for this breed, the minimum body weight, and then this greenish line indicates the feasible body weight for conception. And here you see the graph coming from the parameters around lactation. So this gives you an idea of how the input breed parameters look like. This is then a screenshot of the initial herd composition. Again, that is specified in the same Excel file, just in a different sheet. So for example, here there is an ID for the breed. You give the sex of the animals, you give them the age at the beginning of the simulation, you give them the initial body weight, etc. Okay, then we've got feed input data, of course, also very important. Those are coming in at monthly time step. 3 types of feed can be specified for the crop residues, for the concentrates, and for the grazing land. So in total, in fact, 3 times 3 feed input lines can be specified. And that feed input can be specified also for different animal types. So you can say, for example, well, I want to feed my lactating cows a better diet than my bulls, for example. And that is what you do here. For the different animal types, you can specify different feed preferences. And then we distinguish between feed quantity, so the available biomass per animal, and then the feed quality. And then the most important parameters in terms of feed quality are the dry matter content, the digestibility, the metabolizable and gross energy, and the crude protein content. This is then a screenshot of the feed quantity input. So you see here there's 3 different forages that can be specified, 3 different pastures, and 3 different concentrates. And here you look at the input for 1, 2, and then half a third animal class. But in total, you can specify this for 7 different animal classes, and here you get then the months of the year. So here we're just looking at pasture input data, and you can clearly see a seasonal trend. In January up to April, let's say, there's plenty of feed available, and then it goes down into the dry season. And then we've got a couple of miscellaneous input data. Those are around simulation settings and herd management variables. I'm not going to list them all, but here you see again a screenshot of where you tell the model those settings. So that's not so complicated. Okay, and then we have a slide on model output data. We store monthly values for a large number of variables for each animal. Here is just a selection of that output. There's much more, but these are important ones. So we talk about body weight, milk production, feed requirements, actual feed intake, information around calving, lactation, and manure production. And then the output can be consulted within R, but also the annual values at the herd level, they are written to CSV files that you can then use in Excel or any other software you would like to use them. Okay, yeah, so let me pause again here for a little bit to see if there's any questions on, let's say, model input and model output.
Hi, Kathleen, there's one from Subhash. He asked, as you mentioned, LivSim used for cow, whether LivSim can be used for buffalo.
Sorry, I didn't get that because there's quite a lot of background noise at the moment. Can you repeat?
Sure, and is there a phone caller who maybe is not muted? Fortunately, I can't tell who it is, but if you are calling on the phone, please make sure you mute. That's better. As you mentioned, LivSim is used for the cow. Can LivSim also be used for buffalo?
Well, so yeah, that's a very relevant question, and we've had a lot of questions also on whether LivSim can be used for small ruminants like sheep and goats. So so far LivSim has been parameterized, tested, used only really for cattle, for cows. We have ongoing work for small ruminants, but yeah, I don't think we are confident enough about the model that it is ready for use already now in the second phase of AgMIP. Perhaps if we continue in the future, a small ruminant version of the model will be ready. And for buffalo, well, not yet, but I mean, I can imagine that it comes down basically to a different to specifying a different breed. And then if you have good data, enough data to specify all these parameters, then perhaps we can make an approximation for buffalo. But I think we would need some expert advice on that as well. I mean, I'm not so familiar at all with how different buffaloes are from cows. So yeah, I'm not so sure whether we can easily do it.
There's a question from Patricia. Catherine, regarding available feed, can you do initial runs to determine deficits so one can be able to input the right, the right quantities of supplements?
I think that will be, in a sense, it is possible. But what I would suggest you do there is to basically calculate it with a simple model of feed requirements versus feed availability, and see how big the gap is, and then say, okay, we need so many concentrates to fill that gap. I would probably not use, well, you could use LivSim for that for, let's say, a limited number of years, but if you run it over longer time periods, then you have all kinds of herd dynamics that will come into the way, and I mean, animals will lose weight to compensate for the feed gaps. So it's yeah, it's a bit complicated, but I think you could make a very good approximation by doing some back of the envelope calculations, so to speak, and then use the outputs of that to calculate your concentrate needs or your supplementary feeding needs.
Okay, there's another one from Shoman. How many animals can we run at any given time?
There's no limitations in theory, so you can start your run with one animal, but you can also start it with 100 animals. Of course, the simulation time increases as you increase your herd size. So running simulations for many years for very big herds takes a lot of time. But apart from that, there's actually no limit.
Do you want to take another one at this point, or do you want to
maybe one more? Let's do one more.
Olivier wants to know, do you have already or plan to create a guideline to run the LivSim in R, like the climate document that exists?
Yeah, we are working on guidelines, and we will bring a first version with us to Vic Falls. And I'm sure we will be updating it as we go during the workshop, as we will see where the needs are of the different people. Because for us, this is also quite new, training people in the use of LivSim. So I think we also will learn a great deal. But so yeah, the short answer is yes. Okay, so I will move on, I think, otherwise we'll come into time constraints. So a little bit about data requirements then for model calibration and model use. So in terms of the calibration, important breed characteristics are the potential and the minimum growth curves. And these can be derived from body weight data. And you see that here. So the dots are the actual body weights. And basically the envelope curves, they determine the minimum and the maximum body weight for different ages of the cows. And here we're looking at the Mashona breed, which is a typical Zimbabwean breed. If you have also data on both body weight and feed input data, then the model can also be tested by comparing the simulated against the observed body weight. And so based on that, parameters can be adjusted. And so here we're just looking at some examples from Niger, actually. So I think that's quite clear. Then in terms of milk production, again, having data on daily or monthly milk production over time is important to construct those lactation curves. And if you complement milk production data with feed input data, the model performance can also be tested and parameters can be adjusted. So to summarize data that is needed for model calibration, ideally that comes from feeding trials and from on-farm measurements. And the data needs to be on body weight, on calving rates, on milk production, and ideally that comes in combination with feed input information. And when we talk about feed inputs, always we are not only talking about quantity, but also about the quality of the feed. And so that data can come from, it's experimental data that can come from existing databases, from reports, from publications, etc. Then in terms of model setup and use, you will need information on farming feeding practices, so and on the feed calendar and on feed availability. So we need to know in which months the farmers will feed crop residues, will feed different forages, from which crops, and also to which types of animals. And then, so that is the on-farm fodder availability. And then for the rangelands, we need to know in which months the livestock are relying on the rangelands, and whether that is 100% or 70% or 20%, etc. And again, whether it differs between the different animal types. So this is data that can come from household surveys, from focus group discussions, but also from, I mean, if you don't have data from surveys, let's say, you could also consult experts, people who know a lot about the farming systems in your region, and they could also probably provide you with information on that. Thirdly, we need data on grazing lands, on the biomass productivity from the grazing lands, and ideally we have that in relation to climate variability. And so this is data that could come from biomass assessments, maybe also from remote sensing analyses, and I can imagine you find that data in databases from your institutes, for example, in reports, in publications, and so on. And then finally, quite important also is to have information on the feed quality. So remember, when we talk about feed quality, we talk about digestibility, metabolizable energy, crude protein content. And we need that for the different feed sources. So for the forages, for your crop residues, for concentrates, for grazing land, and also over time, because often feed quality varies over time. If you just take the grazing lands, in the rainy season, the quality will be much higher than in the dry season, for example. And so that is data that comes from laboratory analyses, not from remote sensing analysis. That is wrong, and from that's something you can find in databases, again, reports, publications. Okay, are there any questions on data requirements? I think this is quite important, and we've also shared with Cheryl, who put together the data requirements for the different teams within AgMIP. And a summary of this is also available on the VicFol's website. So you can take this slide, but you can also have a look at the website to see what the data requirements for livestock modeling are. But if there's any questions on it right now, we can also discuss it briefly.
There's a question from Subhash. He says, what are the input climate parameters to run the model, not mentioned in the model input data?
Yeah, okay. I'll actually talk about that in the next slide. So let me answer it then.
Okay.
Any other questions?
Is someone calling in from the phone who wants to ask something? No? There's one from Joseph. Can you use this modeling for animals on veld?
For animals, sorry?
On veld, V-E-L-D? Not sure.
Yes. Yeah, I mean, if you have information on your veld productivity, how much biomass is produced and what the quality of that biomass is, then for sure you could use it.
Okay. David asks, in extensive livestock production system, can LivSim incorporate rainfall data as the major predictor of forage availability and hence mobility and animal performance?
Yeah, okay, so that is also something I will talk about later.
Okay.
In terms of animal mobility, that is not really something that LivSim takes into account in great detail. So we talked a bit about walking distances, but that is, for now at least, a rather fixed average parameter. We could incorporate different walking distances in different months of the year, and we could let that depend on climatic conditions. I mean, that is the good thing about LivSim. Those things are all flexible, and we can all build it in as needs arise. So I think that could be a good one to play with, definitely in terms of looking at climate risk, etc. So yeah.
There's one more from Ken. He asks, you list grazing land productivity, but isn't this something coming from the crop or pasture models?
Yeah, so that's again, I will talk about that in a minute. So maybe I'll move on because apparently there's a couple of questions that I will deal with. So yeah, I mean, where does LivSim fit within the AgMIP Regional Integrated Assessment Framework? So I showed a similar slide also 2 weeks ago, but now I've put LivSim really in the center of our framework because it's the focus of today. And so basically this is where how you can portray it. So let's have a look. So the first thing to note is that there's no direct arrow from climate to livestock. So that's also something I explained last time. It's that we are not, in LivSim, we are not taking into account effects of temperature on animal productivity. So the only way we simulate effects of climate change on livestock is through effects on grazing land, and so the biomass that becomes available on these grazing lands, and through the effects of climate on on-farm fodder production. Okay, so that's an important thing to note. And then when we talk about grazing land, and so the simulation or the assessment of the availability and quality of the biomass coming from the pastures. Well, basically, there's a couple of options on how to incorporate that in the integrated assessment. So one option is to really run a process-based rangeland model. And we gave an example of such a model 2 weeks ago. An example is the Savannah model. So that's one option. Another option is to simulate grass production in a crop model, whether it's AbSim or DSAT. yeah, so that's another option. A third option is to use information on rainfall use efficiency of rangelands. So that's basically a factor that tells you how much biomass is produced with a certain amount of seasonal rainfall. So with these three first options, you are able to take into account some variation in biomass production as a result of variation in climate. The fourth option is just to take average availability of rangeland biomass. So 4 options, and I think the option you choose as a team really depends on the data and the knowledge that you have available on these grazing lands. For all these options, you will need information on the area of the grazing land and on the stocking density, and that because that will allow you to calculate how much biomass is available per animal. Okay, so then we move on to the crop model aspects. So here the crop model will provide input to LivSim because it will tell us how much crop residues are produced on farm, and potentially how much forages are produced. And to be able to use the yield data that comes from the crop model, we need to also have information on the field sizes of these different crops. And for that, we will need household information. That household information basically allows us to calculate on-farm fodder production based on yield data. And then, well, finally, something more on the household information. So I already mentioned that we need information on which crops are grown and on what areas. And additionally, we need information on the herd size and the herd composition of the households. Okay, so basically what we then did is we developed a script to take all these things into account, so to allow us to calculate the available feed every year of a, let's say, 30-year simulation run. And we built this script also to allow you to loop through an entire household database. And so you go from household 1 up to household whatever 147. And for each of these households, you read in the information on the herd composition and on the field areas, which you need to calculate the available feed. And then the model output that is then used in the economic analysis further down the line in our integrated assessment, well, that is basically the annual summaries at household level for milk production and herd dynamics. So in terms of how many animals can be sold, how many animals died, and the evolution in the herd size. Okay, so I have one example to end the webinar, but I'll take any questions perhaps on this scheme if there are any.
I don't see any new questions right now, Catherine.
Okay, well then I'll move on to the example. So here I've just taken an example from our CLIP work. So we're looking here at a section of our household database. I just took out 10 households. I think in total our database is 460 odd households. And so you see here that, well, from these 10 households, there's actually 5 households that have animals. And here you see their cropland areas and their maize area. And so from the crop models, we receive information on the maize stover yields expressed in kilograms per hectare. And we get 2 different maize stover yield categories based on the soils and the fertilizer use of the different households. So that information is used to calculate the total stover availability per farm. So now these are not yields, but these are the total production of crop residues. And then expressed per animal, so divided by the number of animals in each household. And here, basically, you see only 4 lines, and that's because one line was really an outlier here, so I left it out. And this is the information we used for the pasture biomass availability. And so you see here that there's a feed gap from the pastures in the dry season, and it's in these months that we feed the crop residues to the animals. So that is done in the script in R that we built around the LivSim package. Okay, so yeah, that is something that you will have to specify for your particular region, because it depends on the actual feeding practices of the farmers in your region. So here for Zimbabwe, well, the animals rely on the rangelands in the rainy season, and in the dry season, the maize crop residues start playing an important role. Okay, well then we can have a look at the output. So this is now, for example, the monthly milk production for a cow that was in our herd at the beginning of the simulation. And so you see that this particular cow went through 3 lactations, and after that it was replaced. Here you see the corresponding body weight of this one animal. And here you see the same results, but for all the animals in the herd. So here you see that, yeah, it looks already a little bit more complicated. And this tells you that, well, you will have to also come to some summary productivity indicators. And here you see, for example, the annual milk production for the entire herd for one household. And you see that there's quite some variation from year to year. And then this graph shows you what the annual milk production can look like for the 5 households in our group that had cows. And again, this shows that there's quite some variability, not only from year to year, but also between the different households. And that is related to the amount of fodder that is produced per animal on these different farms. And another way of presenting that is then, well, putting the households here on the x-axis and showing the median and the variability with box plots. So here the variability is the variability between the 30 years for which the simulation was run. Okay, so that was it. We've ended with an example, and we have about 10 minutes left for questions.
Hi, Katrine, this is Alex. Can you hear me?
Yeah, I hear you.
So is herd size information included in the economic surveys typically? And likewise, maybe as a follow-up from that, what type of larger data sources might we get to validate these models in terms of, is there anything like an FAO milk production given at country level, or even better, district level in some countries?
Okay. Yeah, herd size is usually part of your household data coming from surveys. So usually questions on how many, even animal types. So farmers are asked questions about how many calves do you have, how many lactating cows do you have, how many oxen do you have. So yeah, usually that information is captured. And if not, it would be something that the teams would have to collect or at least get estimates about. And then in terms of the validation of the model, well, usually in the survey data, information on milk production, for example, is included. Information on calving rates is included. Information on the offtake rates is included. So I guess just as the crop modelers compare their crop yields, their simulated crop yields with farmer reported crop yields, the livestock modelers will have to compare simulated productivity indicators with the estimates from the farmers. In terms of larger scale databases, yes, I mean, just as for crops, the FAO provides information on meat and milk offtake rates, but yeah, I think just as with farmer estimates, you can question the quality of that data. So I'm not sure if we can use country average data to validate a farm level model. I think that's probably a bit difficult.
Yeah, I think my main interest would be to find some way of saying, yes, this model does reproduce the bad year or the good year well, and maybe not on a one-to-one basis, but if there was a large signal, if there was a really bad year, we would hope that might show up in FAO, and also hope that it might appear in our
yeah, okay, yeah, that makes sense.
Catherine, there's another question from Ken Booty.
Yeah.
He asks, it looks like rainfall pattern and dry season rainfall shortage is a dominant driving feature. Is production really as variable as you show?
Rainfall is indeed a driving variable because it determines feed availability, and indeed feed availability is the driving variable behind animal productivity, because I mean, at least in systems where supplementary feeding doesn't play an important role. So if we look at the systems we simulated in Zimbabwe, I mean, farmers do not use concentrates to supplementary feed their animals, and so they are quite vulnerable to shocks. There's very little mechanisms to absorb those shocks coming from climate variability.
Okay, Harbir Singh asks, research shows temperature affects milk yield, but LivSim does not consider it. Any comment, please?
Yeah, okay, we talked about that 2 weeks ago as well. And yes, indeed, there is research that shows that temperature affects animal productivity. A lot of that research is from very intensive systems in temperate climates. And in the extensive livestock systems that we're looking at least for many of the sub-Saharan African systems, I think it is a challenge to include that. As I mentioned 2 weeks ago as well, we talked about this with the livestock group at the Global AgMIP workshop in Gainesville. And the livestock experts there advised me to make a long story short, to leave temperature aside for the moment. And their argument was that in these systems where rangeland grazing is very important, when temperature increases, animals would compensate that by just staying in the shade for longer. So yeah, maybe a bit of a simplistic answer, but yeah, I mean, I'm open to compare LivSim with a model that does include temperature influences. I mean, AgMIP is all about comparing models and improving models. So if people are familiar with models and are using models that do include temperature effects, then we can incorporate them, and we can make comparisons. I think that would be very interesting.
Katrin, I don't see any other questions, except that there was a request for the recording. So yes, the session is being recorded and will be available in the webinar section of the Vic Falls workshop in probably by tomorrow.
Okay, cool. Great. Well, if there's no more questions now, then we can end the session here, and I'll end with saying that we really look forward to working with all the livestock modelers and meeting all the livestock modelers in Vic Falls next week. I think it's really exciting that we will move this livestock modeling forward in the second phase, and I'm really looking forward to that. So thanks everyone for your attention, and see you soon.
Thanks, Katrine. Take care.